Hey there, Geometry. It's Mr. Lamb, and coming to you with the retake of the Unit 6 test. This is the one that includes the line partitioning, and I'm coming to you tonight with the key for that. It's going to be 4 pages long. A little bit about the test. First of all, it was out of a total of 26 total points. So there are 26 things, and you'll see in that mint green color, those are the points that each question is worth. So as you're checking your own test, you can kind of check and see how many points you earned out of the totals. If you use the note card there in the middle, it says 22.1. That is how many points you could have earned out of the 26 by using a note card. One page, the max you could have earned is 19.5. And using unlimited notes, the most you could have earned is 16.9. This did go into the grade book as a grade times 4. So this test is actually out of 104 total points. Your score times 4. All right. Well, with that being said, let's go ahead and jump right into this test and take a look at Unit 6 test, section number 1. This was the new stuff after the Christmas break. We really did a nice job on question number 1. I was pretty happy across the board with how we did. And this is partitioning a line segment. You'll notice that throughout the test, I've already pre-graphed all the points and lines and everything, have everything labeled, so it's already set and ready. You'll want to make sure that you double check to make sure that your points are in the right location, but it'll just save me a little bit of time as I go over these. So partitioning a line segment. The first thing I'm going to take a look at is I'm going to look at this ratio, and it says it's a 3-to-1 ratio, and 3 plus 1 equals 4, so that means I'm going to have 4 pieces that I'm going to divide everything into. All right, so what am I going to divide up? Well, I'm going to divide up the slope, and that's the change in the y and the change in the x. So I'm going to calculate the change in my x values, first of all. All right, now my change in my x values, I am calculating from point A to point B. Right, I'm going to go from A to B because that is alphabetically how it shows up. So in order to get from the A value to the B value, I have to go to the left. And I have to go to the left 6 units. So since I'm going left, this is negative 6. And my change in my y values from point A down to point B, I'm heading down. And that's 8 units down. So my change in x is negative 6. My change in y, as it went down, is negative 8. All right. Now, I said that we broke this thing into 4 pieces. Let me put that in blue. 4 pieces because of the 3-to-1 ratio. So that means my change in x, which was negative 6, I'm going to divide that into 4 pieces. And my change in y, the negative 8, I'm going to divide that into 4 pieces. All right, well, negative 6 divided by 4 is negative 1.5. And negative 8 divided by 4 is negative 2. Right, that's how I'm going to change my values. So again, I started at point A. When I did my change in x and change in y, I went from point A to point B. So I'm going to list point A first. It is at the point 8, 5. And I'm going to add some points in between until I get down here to point B, which will be down at the bottom, and it is the point 2, negative 3. So I need some points in between those two. Now, some of you knew the little shortcut here, and I said, how many points go in between? If there are 4 pieces, there are 3 points in between. That's what makes up the 4 pieces, is you break it 3 times, and you keep breaking it in half, and break it, that next piece off, and break another piece off. Okay, so how do I change my x's? My x's change by negative 1.5. So I'm going to subtract 1.5 from my x value. So my x value is 8. Subtract 1.5. 8 minus 1.5 is 6.5. And then I do it again. Subtract 1.5 again. 6.5 minus 1.5 is 5. I do it again. 5 minus 1.5 is 3.5. And then I do it again. 3.5 minus 1.5 is 2, which is the value I need for my B point. So I can see that I have subtracted 1.5 each time, and now I hit the 2 value, which is what I was hoping to get to. All right, now how do my Y values change? How does the 5 change? I look over here and it says subtract 2, so go negative 2. 5 minus 2 is 3. 3 minus 2 is 1. 1 minus 2 is negative 1. And negative 1 minus 2 is negative 3. So I can see now where each of those points come from. Now the problem asks me for the points that have a ratio of 3 to 1. So I'm not, the black points are given. The ones in green are the ones I'm looking at. And if I look here at the point negative 6, 5, I can count how many points are above it. There's 1 versus how many are below it. There are 2 green ones and a black one, so there are 3. That point has a 1 to 3 ratio. Okay, this next one, 5, 1, has the black point and 1 green point above, so it has a 2, and below it a green and a black, a 2 to 2 ratio. The next green point has 3 points above it, 3, and below it 1. So the problem says find the one that has a 3 to 1 ratio. Well, this one right here, I just see it. That says 3 to 1 ratio. So 3.5 comma negative 1 is one of my 2 answers. The other answer is if that ratio happened to be reversed. So I'm looking for the 1 to 3 ratio, which is 6.5 and 3. So I told you this question is worth 3 points. You got 1 point if you started setting the problem up correctly, but your math was wrong. And then the other 2 points were for picking the proper 2 points that partition that segment. So you got a point for each one of the correct points, and then you got 1 point just for getting it set up. All right, question number 2. Determine if the quadrilateral with the following vertices is a trapezoid. Justify your answer. So is this a trapezoid? Well, the first thing I need to know about a trapezoid is what is a trapezoid by definition. And a trapezoid by definition has 1 pair of parallel and 1 pair of non-parallel sides. So I have to get 1 pair to say yes to parallel and 1 pair to say no to parallel. And then I have a trapezoid. Unfortunately, the point C runs off the graph, but okay. You'll notice I just plotted the point out there. I'm just counting, so it's no big deal. So the first thing I'm going to do is looking at this picture, I can tell it looks like AB and DC may be parallel. So I'll start there. I'm going to find the slope of these points. So let's analyze the slope of 2 points. So let's look at the slope of AB, and let's look at the slope of DC. All right, from A to B, I'm going to make my little triangle here. So I'm going up, 1, 2, 3. Going to the right, 1, 2, 3, 4, 5, 6. So slope from A to B, rise is 3, run is 6, and that reduces 3 over 6 reduces to 1/2. Had a lot of people not reduced this correctly, reduced it to 1/3. Be careful, you're dividing both things by 3, not by 2. All right, now for the DC one. And this one is the interesting one because it kind of runs off the page. And it's coming down and I really don't know. So I'm going to have to look at the heights. So my D, point D, if I look at its x value, it's at 3. And C's x value is at 13. So that segment is going from 3 all the way over to 13. So that tells me that that is 10 units long. Now let's look at the heights. The height at point D, it's up 1. At point C, it's up 6. So the difference in height from 1 to 6 is it goes up 5. looks like a 6. That's a 5. So my rise from D to C, it rises 5, and it runs 10, which is a slope of 1/2. So my question is, look at these two slopes. They are both equal to 1/2. So that means that these two things are parallel. They have the same slope. Okay, so that's good. A trapezoid, I have to have one pair that's parallel. The other pair is not allowed to be parallel. So let's look at pair number 2. So this I'm good with. I needed that. Pair number 2, I'm going to look at AD. I'm going to look at the right side, BC. All right, from A to D, the rise goes down 1, 2, 3, 4, down 5. It goes to the right 2. So A to D, it goes down 5, which is -5. It goes right 2, which is +2. And that does not simplify. It's just -5/2. From B to C, it's going over some amount and it's going down some amount. Again, this one's kind of out in the wilderness. So from B to C, let's find its rise. B is up at 9. C is down at 6. So to get from B to C, that is a drop of 3. From 9 down to 6. Over the run. So I'm running from B to C from 7 all the way out to 13. Well, 7 to get to 13, you have to add 6. So I have a drop down here of 3 and a right run of 6. Well, -3/6 reduces to -1/2. And as I look at these two segments, -5/2 and -1/2, these are not parallel because they are not equal. So I have a 4-sided figure that has one pair of parallel and one pair of non-parallel sides. So the question is it a trapezoid? My answer is yes. Because one pair of sides are parallel, and the other pair are not. And that is a trapezoid by definition. So one pair is parallel while the other pair is not. All right, that's the end of page 1.